Okay, in this presentation we are going to look at an exponential distribution worked example. There's a little bit about the binomial distribution in this as well. Okay, so the number of minutes late that students arrive at a lecture is a random variable following an exponential distribution with mean of 5 minutes. Now, in this question we're going to assume that we're only talking about the late students. So if students arrive on time, they're not really part of this question. Okay? Determine the probability that a student is more than 10 minutes late to the lecture. And 20 students arrive at the lecture independently of each other. Determine the exact probability that fewer than 2, that's probability of x less than 2, where x is the number of students that arrive, are more than 10 minutes late. Okay, I'm getting into two different questions here. So this is really an exponential distribution question, and this is a binomial distribution question. So let's just look at them separately. Okay, now, so first off, what we're going to do here is look at the probability density function of the exponential distribution. Okay, so the probability density function of the exponential distribution is given as follows. That's actually, sorry, I'm actually sort of focusing on that, but the couple of details I want to focus on here is the rate parameter and its relationship with the mean. So the mean and the rate parameter are the inverse of each other. Okay, so the mean is like the average waiting time, and the rate parameter is the inverse of that. We denote the rate parameter lambda. Okay, that's the key thing there. So for what our purposes, this is actually probably more important than this one here. Okay. So the cumulative distribution function is given by as follows: probability of x less than or equal to some value x, or x is the period, waiting time, that sort of thing, the lifetime. That is equal to 1 minus the exponential of minus lambda x, where x is greater than or equal to 0, or 0 otherwise x is less than 0. Now, just to sort of equivalently, we could sort of say probability of x greater than 0 equals the exponential of minus lambda x. And again, we're still assuming that x is greater than equal to 0 in this case as well. Okay, so this is really what we're going to be using here. So the question asks us, determine the probability that a student is more than 10 minutes late. So that is the probability of x greater than or equal to 10. Okay, or greater than 10. Actually, it doesn't really matter too much about the greater than component, but let's just be consistent. Okay, it's the probability of x greater than 10. So the mean waiting time, the mean lateness time is 5 minutes, and that means the rate parameter is 0.2. So essentially, this is how we would sort of specify our distribution, where x is the waiting time in minutes for arriving late. We would specify it as follows. So the probability of x greater than 10 is simply the exponential of minus 0.2 times 10, okay, and that is the exponential of minus 2, and that should give you an answer of 0.1353. Okay, good stuff. Now, so in this question, what we're going to look at is the binomial distribution. So we're looking at the second part here. I'm just going to scroll up here for a second. 20 students arrive at a lecture independently. So that's our sample size there. N is equal to 20. Okay. And determine the exact probability that fewer than 2 are more than 10 minutes late. Okay. So just actually, for the sake of clarity, I'm going to rename this variable y. Okay. What we're also told in this question is the probability of a success. So let y be the number of students arriving more than 10 minutes late. So y is the name of our variable. It has a binomial distribution with a number of independent trials 20, sample size 20. It's a little bit not perfectly accurate to say sample size. Number of independent trials is the correct thing, but people know what you're talking about. And the probability of success is 0.1353, which we've determined from part A. So what we're asked to compute here is, I made a mess of this. I said I was going to call it x or y, and I'm calling it x here. So what we're asked to do here is find the probability of y less than 2, okay? And that is, breaking it down, probability of y equal to 0 plus probability of y equal to 1. Okay, so essentially what we have here is two calculations here. And again, I'm going to just change that to y very quickly. So we have two binomial calculations here. Probability of y equal to 0 is 20 choose 0 times 0.1353 to the power 0 times 0.8647. That is 1 minus 0.1353 to the power of 20. In other words, okay. 20 choose 0, that gives us 1. Anything to the power of 0 also gives us 1. 0.8647 to the power of 20 gives us 0.046. So that's the answer, the probability of y equal to 0. Likewise, we repeat the calculation for probability of y equal to 1. 20 choose 1, that's 20. 0.1353 to the power of 1, that's 0.13 to the 53. Simple as that. And a very simple, similar calculation to what we've done before, 0.8647 to the power of 19, bit of calculator work, 0.0631. And that should equal to 0.1707, allowing for a bit of rounding error, okay? So essentially what we do to get our answer is we add these two numbers there, and we get an answer close to 0.2253, okay? And again, rounding error might come into it. Anyway, that's it. We'll leave it there.